Good morning, this is Mr. Tuttle, and I'd like to discuss the two kinds of t-distribution problems. Problem 1 is finding the t-value when you know the probability, and problem 2 is finding the probability when you know the t-value. This video will discuss problem 1, and the next video will discuss problem 2. First, let's take a look at the t-table in Appendix A-3 in the back of the book. This is an abbreviated version of it. Notice that it's quite different than the normal table. A t-table has 3 decimal place t-values in the body of the table, degrees of freedom going down the left column, and 1 and 2 tail probabilities in the column headings. For this course, the degrees of freedom in a t-problem equals the number of items in the sample minus 1, that is n minus 1. So for our first problem, suppose we want to find the t-value so that the probability that the t is greater than that t-value is 0.025. with degrees of freedom equals 39. In all these t-problems, I like to start by drawing a rough curve with the t-axis on the t-values on the horizontal axis and shading in the area I'm interested in. Here we want a right area of 0.025 for some unknown t-value. So now, how do we find this t-value? To use the table, since we want a one-tail probability of 0.025, and degrees of freedom of 39, we go down the 0.025 across the 39, and the t-value is 2.023. To do this in Excel, the formula is equals t.inv 0.975, 39. Now, why is it 0.975? That's because t-inv gives the left tail probability. If the right tail probability is 0.025, the area under the curve is 1, so the left tail probability must be 0.975, and that gives you 2.023. Now, how do we do this in StatCrunch? To do this in StatCrunch, go to My Stat Lab, go to a problem that has StatCrunch as an option, click StatCrunch, click Stat, click Calculators, click T, and you'll get something like this. Enter 39 as degrees of freedom, and now you have the probability of x less than or equal and 2 boxes. For this, we want probability x greater than or equal. We want an area of 0.025. Click Compute, and there's the same 2.023 as we got in the previous problems. Let's do another one. Suppose we want the t-value, so its left probability is 0.025. Shade in the area here. Now notice that this is going to be a negative t-value. But our table only gives positive t-values. But if the right area of 0.025 gives you a t of 2.023, since the t-curve is symmetrical around 0, the left t-value is just going to be negative 2.023. So there's no negative value in the t-table, but you use the negative of this 2.023. When you enter this in Excel, you do enter 0.025, the left value, and it gives you directly negative 2.023. Let's do another one. Suppose this time we want a 95% confidence interval. That is, the area under the curve is 95%. We want the t-values corresponding to that. So if this area is 95, the area to the left plus the right is 5. Each of them separately is 0.025. Well, this is a combination of the problems we just did. We know that for a 0.025 area to the right, the t-value is plus 2.023. To the left, it's minus 2.023. So your t-values will be the two values plus or minus 2.023. Now, one more tricky one. Let's do the same problem as we just did, except with degrees of freedom equals 48. Well, the 48's a little wrinkle because the t-table does not give you degrees of freedom of 48. It gives you 45 and 50. Well, 50 is closer to 48 than 45 is, so if we're going to use the table, we have to use the 50 value, which is 2.009. A better answer will be to use t-inv with the 48, which will give you 2.011, or StatCrunch, which will give you the exact values. So these are your basic t-probability calculations. They're not too hard, but they certainly come up a lot, so do practice them. You have a choice of 3 ways to do them: the tables, Excel, and StatCrunch. So decide which way you like best.